In this example, we are going to start looking at solving exponential equations. And most of the time, this process that I'm about to explain is what you will be using, unless you have the same basis on two sides, or you can transform them so that they have the same basis. Then you have a certain way you're supposed to solve these. Exponential equations usually will have the unknown in the power. That's going to be what you will try to find. Now, there are a couple of things you can do it. The easiest thing to me is to apply log to both sides. Now, which log does not matter. If you like natural log, you can apply natural log. If you like common log, apply common log. So I will apply natural log because I like this better, but whatever, it's up to you. Okay, so I am applying natural log to both sides. In fact, natural log is a one-to-one function, so you can always apply it, because if the two arguments here are the same, then that their logs are the same, and vice versa. That can be shown. All right, now what we will use is the power rule for the logs. So whenever we have the argument raised to some power, that power could be moved in front of the log. That will make it x natural log of 3. And then on the other side, we got natural log of -2. So as you're about to solve something like this, you're going to divide both sides by natural log of 3. And then you will just put it on a calculator. But there is going to be a but. As you start putting it on a calculator, and this would be something like log of -2 divided by log of 3, because this is just going to cancel on the side. And so if you try to do that, the calculator tells you that it's undefined. Why is that? Well, that's because logs of negative numbers are undefined. What that means is there is no way 3 to the power x can be equal to -2. In fact, when you raise a number to a power, if it's a positive number, you will never get a negative answer. So here we type D and E. This equation has no solution, even though it looked like it did, but we can see that it doesn't. Okay, so that was part A. But let's see what happens on the second one. On the second one, I'm pretty sure we will be able to solve it. So here we got 5 to the power x equals 7. Again, the unknown is in the power. So apply natural log to both sides. Okay, and use the property that it doesn't matter whether you applied it or not. The two sides will be the same. And now use the power rule of the log. So x will be moved to the front, and we got x natural log of 5 on the left-hand side, and then we have natural log of 7 on the right-hand side. Now, to solve this for x, divide both sides by natural log of 5. Be very careful not to put it like inside. It's not natural log of 7 over 5. It's natural log of 7, that whole thing, divided by natural log of 5. Okay, so here it's going to cancel. Let's see if the calculator gives me an answer here. So I can do natural log of 7 divided by natural log of 5. And it does. Now, it wants me to enter an exact answer. So I really do not know what it wants. I think I'm going to try to put it this way. It cannot be simplified any further. You cannot like cancel ln, for God's sakes. You cannot do that. And that's not 7 over 5. Okay, so that's what it wanted.